Hello everyone. In this video, I have built a machine learning classification model to predict whether the energy demand will be high or low based on various features such as weather conditions, day of the week, and historical energy usage. Firstly, I have imported the necessary packages and libraries which are required to create a model. Next, I loaded the dataset from an Excel file using a pandas. This dataset includes features like historical demand and weather data and whether the day is holiday or not. Next, the target variable, high demand, is created by comparing the energy demand to its average value. If the demand is higher than the average, it is classified as high demand, and otherwise it is classified as a low demand. Nextly, I separated the features X from the target variable Y. Columns like a date time and a demand are dropped as they are not used for the predictions. Next, I have splitted the dataset into 80% of training data and 20% of the testing data to ensure the model to be evaluated on unseen data too. Next, I have trained the model. I used Random Forest Classifier, which is an ensemble learning method. It combines a multiple decision trees to improve the model performance and reduce overfitting. This model was trained on the training data to learn patterns in the data. Finally, I evaluated the model. I used the classification report to show precision, recall, F1 score, and accuracy for both high and low demand predictions. To reuse the model later, I saved it as a file demand_classifier.pkl using the job library. This allows us to make predictions without retaining the model. And then I'm going to making predictions with a new unseen data. For that, I have just imported the necessary pandas library and joblib library. The next is I loaded the saved model to make predictions on new data. And the new data is structured in the same format as the training data. I also applied the same pre-processing steps such as one-hot encoding to ensure consistency with the training data. To ensure with the feature columns match the model expectations, missing columns are added with the default value of 0. The column is then adjusted to align with the training data. And then making predictions. Using the predict method, the model classifies whether the demand will be high or low based on that. Then the output is converted to human readable labels. So I am just using that high demand or low demand labels. And the model also provides the probability for each class. For example, it might indicate a 70% of chance of high demand and 25% chance of low demand. And it predicting based on that. And the new predictions are low demand and the prediction probabilities are shown here. And finally, the model successfully predicts whether the energy demand will be high or low based on the historical data. And that's it. Thank you.